since she is going to be planning this party, she is going to wake up very early. Hey everyone, my name is Venelin, and in today's video we're going to have a look at some pretty cool paper called Generative Agents. So what this paper is about, essentially what the guys from Stanford and Google research did was to hook up ChatGPT to a small environment comprised of 25 agents, and they gave some memory, they gave some higher order goals for those agents, and then created a virtual world or a small town in which we can observe their interactions, and you can essentially have a look at how they're going about their day and how do they execute on their goals. Let's have a look. I found this tweet by Andrei Karpathy, and he says, love it, much fertile soil for indie games populated with auto GPTs. So yeah, it puts open world to shame. Simulates a society with agents, emergent social dynamics. And here is the links to the paper and the demo. But Lior from Alpha Signal has done a great summarization of what this paper is all about. So it says that by using large language models, generative agents were able to simulate human-like behavior in interactive sandbox inspired by The Sims. So what we're looking at is essentially a sandbox or a game in which you can simulate human behavior using ChatGPT or GPT-4. And in this example, we have three major components: memory stream, a list of memories of the agents, then a reflection. So this is essentially a synthesis of the memories that were previously encountered. And then we have some planning, and these are the actual actions or concrete actions that the agents are going to do within this environment. And this is really interesting. Layer that on top of Boston Dynamics robots, and we might be the early days of Westworld. Yeah, pretty interesting. This is the paper. It is available on the archive, and it says, or the title is Generative Agents, Interactive Simulacra of Human Behavior. I'm not sure if I'm pronouncing this word correctly, but whatever. It means that we are simulating a believable human behavior or human-like behavior. So you can see that this work is actually a joint work between researchers from the Stanford University and Google Research, which is very interesting. And here is a screenshot of the environment. You can see that it looks like a little game. It is very similar to what Sims used to be in the previous days, with not like very simple graphics here, but it looks pretty cool. And here we have some agents, and you can see even from this screenshot that they're doing some tasks: arriving at school, sharing news with colleagues, joining for coffee at a cafe, taking a walk in the park. And these are different agents that we have here. So it says, Figure 1, generative agents create believable simulacra of human behavior for interactive applications. In this work, we demonstrate generative agents by populating a sandbox environment, reminiscent of The Sims, with 25 agents. So they create an world or simulated world with 25 agents. Users can observe and intervene as agents plan their days, share news, form relationships, and coordinate group activities. And here, of course, the paper is very long, but some of the key points. In evaluation, these generative agents produce believable individual and emergent social behaviors. For example, starting with only a single user-specified notion that one agent wants to throw a Valentine's Day party, the agents autonomously spread invitations to the party over the next 2 days, make new acquaintances, ask each other out on dates to the party, and coordinate to show up to the party together at the right time. So this is just from specifying a single goal at the start. And here is the introduction to the paper. How might we craft an interactive artificial society that reflects believable human behavior? From sandbox games such as The Sims to applications such as cognitive models and virtual environments for over 4 decades. Researchers and practitioners have envisioned computational agents that can serve as a believable proxies of human behavior. So this is a really cool area of research for over 4 decades. For the purposes of this paper, we focus on the ability to create a small interactive society of agents inspired by the games such as The Sims. Okay, so the original Sims games, if you're not familiar with it, it is this. So you have basically those Sims, which are essentially the agents, and they do different things. You put them in some environments, and then you maybe throw a party, create cooking environments, build houses, etc. Really cool game that I used to play when I was like way before. So by connecting our architecture to the ChatGPT large language model, so the researchers are using ChatGPT, we manifest a small society of 25 agents in a game environment, and users can observe and interact with these agents. So they're again talking about this Valentine's Day party. For example, traditional game environments would require scripting tens of characters' behavior manually. So they're essentially setting this goal that is like a social goal, and then they observe the agents what they're going to do just using ChatGPT to understand different behaviors. So in this paper, they provide the following contributions: generative agents, believable simulacra of human behavior that are dynamically conditioned on agents' changing experience and environment. So they have these agents that are working with the environment and they understand it, they have memories about it, they do some reflection, as we are going to see in the next part of the paper, and then they're taking some concrete actions based on the behavior or the memory that they stored. A novel architecture that makes it possible for generative agents to remember, retrieve, reflect, interact with other agents, and plan through dynamically evolving circumstances. So, this is essentially the TLDR of the paper. They are creating agents that can remember so they can have memory. Then they reflect on this memory, so they're doing even higher form of thinking based on the memory or the interactions within the environment. And then what they're doing, they're planning actions and then taking concrete steps in order to execute those actions. So here they have some related work which you can go over. And this is again another look at the whole sandbox. So you have some houses, college dorm, grocery. So this is a very small town with a park, bar, cafe, houses, college, co-living space. So within each unit you have family house with different rooms, areas, and different objects within each room. So it looks like a very small representation of what might a town look like, but it is still very believable and very exact, at least as simulations go. So it says that the Smallville sandbox world with areas labeled. The root node describes the entire world, children describes areas, houses, coffee stores, and leaf nodes described objects. Each agent remember a subgraph reflecting the parts of the world. So you can think of this world as a tree, and then each agent remembers a subgraph of this tree or a subtree. So it might even be, this whole thing might be even represented as a tree, as a graph altogether. So agent, avatar, and communication. So still we have these 25 unique agents, and basically each agent has an initial prompt or a system prompt in the language of ChatGPT. And the authors say we authored one paragraph of natural language description to depict each agent's identity, including their occupation and relationship with other agents, as seed memories. So this is the system prompt or the initial prompt for each agent. And there we're talking about John Lin is a pharmacy shopkeeper, etc., who loves to help people. He is always looking for ways to make the process of getting medication easier for his customers. So John Lin is living with his wife, Mei Lin, who is a college professor, and son, Eddie Lin, who is a student studying music theory. John Lin loves his family very much. John Lin has known the old couple next door for a few years. Sam Moore is a kind and nice man. John Lin knows his neighbor Yamamoto well. John Lin knows of his neighbors, but has not met them before. colleagues at the pharmacy are friends and like to discuss local politics together with his colleague. John Lynn knows the Moreno family somewhat well. The husband, Tom Moreno, his friend, and the wife, Jane Moreno. So this is essentially the each initial memory. Each semicolon delimited phase is entered into the agent's initial memory. So then agents communicate with each other in full natural language. So there is no specific coding between the language between each agent. Agents are aware of other agents in their local area, and the generative agent architecture determines whether they walk by or engage in a conversation. So here's a sample between Tom Moreno, which is John Lynn, essentially colleague in the pharmacy, and Isabella Rodriguez. So Isabella, I'm still waiting my options about the upcoming elections. I'm still waiting my options, but I've seen discussing the election with Sam Moore. So what are your thoughts on him? To be honest, I don't like Sam Moore. I think he's out of touch with the community and doesn't have our best interest at heart. So this is Tom's opinion, and this is an actual conversation between the agents within the environment. So we have example day in a life. So these are some of the conversations and emergent social behaviors right here. So this is an example of a morning routine of John Lynn. So he wakes up around 6 o'clock. Then he brushes his teeth, and this is the time on the X. Then takes a shower, and then he makes breakfast. He catches up with his wife. But why is he cooking the breakfast himself? Strange. Then he's packing some meals, I guess. And then he goes to the pharmacy and opens up the store. Really interesting. So at the beginning of the simulation, one agent initialized with an intent to organize Valentine's Day party. Despite many possible points of failure in the ensuing chains of events, agent might not act on that intent, might not remember to show up. Valentine party does in fact occur with a number of agents gathering and interacting. So I believe that Isabella Rodriguez is the one that is going to be creating this party. And here they're talking about essentially the loop in which the agent is going through. Agents perceive their environment. Yeah, so they save everything in a record, memory stream. So based on those memories, they're determining the actions. They create higher level reflections, and those are also stored in the memory. So the first part is the memory retrieval. The memory stream contains a comprehensive agent's record. So it's a list of memory objects with timestamps. And you can see here we have a memory stream of Isabel Rodriguez. So what are you looking forward to the most right now? Isabel Rodriguez is excited to be planning a Valentine's Day party at Hops Coffee on February 14, and she's eager to invite everyone to attend the party. And the response is, I'm looking forward to the Valentine's party that I'm playing at Hops Coffee. So Isabella is in charge of this, and this is her memory stream. She's doing different things at different timestamps. You can see here. Then we have the reflection, which is essentially looking through observations and creating these higher order memories. So yeah, reflections are generated periodically. In our implementation, we generate reflections when the sum of the importance scores for the latest event perceived by the agents. So once they do some threshold value, they're essentially looking through those reflections. And then finally, they're doing the planning and reacting. Plans describe a future sequence of actions for the agents and help keep the agent's behavior consistent over time. A plan includes a location, a starting time, and a duration. For instance, Klaus Müller, who is dedicated to his research and has an impending deadline, might choose to spend his day working at his desk, drafting his research paper. So let's look at the demo and how the actual agents are interacting with each other within this environment. So this is the demo. I believe it is done in Phaser, which is a 2D environment. And here you can see we are starting at 6 o'clock on February 13th. And this is a pre-computed replay of a simulation. So recall that Isabel Rodriguez IR right here is actually going to plan this party. And these are all of the 25 agents. And we can click on one character to see its current state in more detail. But let's run this and have a look at what is happening here. So you can see that everyone is asleep, but Isabella is waking up, brushing her teeth. She's visiting the shower, etc., the bathroom. So you can see that since she is going to be planning this party, she is going to wake up very early, and probably she needs to do a lot of stuff or preparation before everything is done. And she's going to take a breakfast next. Let's see her state in more detail right here. It's almost 7 o'clock, waking up and completing her morning routine, eating breakfast. And this is the location. So it's almost 7 o'clock. So Isabella is actually going for a run. No, she's going to the Hops Cafe. Yeah. And you can see that almost everyone else is waking up. But of course, Isabella is much, much early compared to everyone else. So Isabella has already opened the coffee, and she's now setting out. So she's preparing the breakfast. And you can see that the other agents right here are looking for breakfast themselves. So Isabella greeting customers. 9:30, and Isabella is talking with her first customer. So this is the conversation. And SM is really happy with the coffee, I guess. You can see that some of the guys are going for a run. And Isabella is still waiting within the coffee. It's 10 o'clock now. A lot of people are outside, so she has more customers. She's talking to everyone. And she's offering pizza, I guess. So at 11, the Giorgio Rossi is talking to Klaus Müller. And here is the conversation. Hey Klaus, how it's going? Good, thanks for asking. Just working on my research paper. Always busy with something. I've been working on a project exploring mathematical patterns in nature for medication development. Wow. Have you come across anything related to that in your research? No, I haven't, but that sounds really interesting. I'm focused on the effects of gentrification in low-income communities right now. I see. Well, I'm also curious about the upcoming mayor election. I heard Jennifer Moore. So you can see that this. Have a good day. This is a really cool conversation between the agents. Let's continue. And let's see how is Isabella doing right now. So she's out of the coffee and having a conversation at the moment with Eddie Lynn. I'm hosting a Valentine's Day party at Hops Coffee. You should come and perform your composition for everyone. So she's already inviting all of the other people to the party and then asking them to, at least in this case, perform something, which is great. She has kept her goal in mind. And she's currently shopping within the grocery store. Let's see her conversation. She's talking to John Lynn. And then again, I'm actually planning a Valentine's Day party at the coffee and I wanted to invite you and your family. So she's inviting everyone, which is great, keeping her goal in mind. Talking to other people, let's see if she's mentioning the Valentine's party. It's almost 3 o'clock, and you can see that Isabella is actually getting ready for the Valentine's Day party, creating a checklist for the party. She's actively working on that, writing out everything that she needs to do. It's after 5, and Isabella is finishing decorating the cafe, setting up the music system. So she planned everything, she bought everything, and now she's finishing the decorations for the party tomorrow. And this is where the demo stops. Unfortunately, we can't see whether or not the Isabella Rodriguez party is going to succeed, but she did everything that she had to in order to prepare for the party. And right now she's going to bed so she can wake up early and start the party tomorrow. In this video, we've seen how you can use ChatGPT to create generative agents, and those agents had memory. They have some sort of a reflection, which is essentially higher order of memory that they can compose based on their interactions with the world. And then we saw how they plan with some concrete actions to execute based on those plans. We've looked through the day of Isabella, and she was planning a Valentine's Day party. So she did everything that she had to. She went to the shop in order to get the necessary groceries. She decorated her place. Then she invited some people around and she prepared everything in order to have a great party. Thanks for watching, guys. Please like, share, and subscribe. Bye.